Hello all. Today in this video lecture we will see non-perpendicular oblique components. In our previous lecture we saw that perpendicular components of force. Now to learn non-perpendicular oblique components we will consider here one point and we will nomenclature that point as A point, and at this A point what will happen, this force F will act. Consider and resolve this F force in an oblique component. So this as Q. So just name this force F here, and this will be R. So this Q and R are oblique components of that F force, and those forces are making an angle alpha. See, this F force makes an angle alpha with component Q, and F force makes an angle beta with component R. Now next what we will do, we will just consider those all forces. Same we will consider here. Just wait. Either we can write like right here on it also. So just see, line of action of this force will be like this, and this Q force will be like this, and this R force will be like this. So what we will do here, just see, this force is like this. So make parallelogram here. So to make parallelogram, first we will, this point is A, this point is B, this point will be C, and this point will be D. So ABCD parallelogram we will make, and how we will make, we will join this CD parallel to this AB, and this BC parallel to this BC. Just consider. So just so parallel to AD, this BC join those components. So see, it is not looking like parallelogram, so just make it parallelogram. So this ABCD is a parallelogram now. So observe here, this angle is beta. So here this angle will also be beta geometrically. And if we will consider triangle ABC, then you all know that all angle of triangles, like sum of all angle of triangles will be 180 degrees. So with the help of this judgment, we are able to write here this angle 180 minus alpha plus beta. This angle. So we will consider this triangle ABC. See this ABC triangle, and we will apply sine rule. So you all know that sine rule is equal to, if we will consider this AB side, and opposite to that AB side angle is beta, so AB upon sine beta. Now next is this, if we will consider this BC side, so opposite to that BC side angle is alpha, so is equal to BC upon sine alpha. Next, if you will consider this AC side, so opposite to that AC side angle is 180 minus alpha plus beta. So sine 180 minus alpha plus beta. So here see sine 180 minus alpha plus beta. So remember that sine 180 minus theta is equal to sine theta. So with the help of that mathematical judgment, we will write sine 180 minus alpha plus beta is equal to sine alpha plus beta. So just write here AB upon sine beta will be as it is, BC upon sine alpha also as it is, upon AC upon sine alpha plus beta mathematically. So just see here, this AB is nothing but the Q upon Q is oblique component of that force F, Q upon sine beta. BC, see here BC. BC and AD are parallel, so they are same. That means here this will also be R, and R is also oblique component of that F force. So R upon sine, because see Q and R are oblique component of that force, and AC is that force where it is acting at point A, upon sine of alpha plus beta. So from this, see this Q oblique component of this force. So this Q is equal to, see this, compare both of these. So Q is equal to this F, take this side, this sine beta take this side, RHS. So sine beta upon sine alpha plus beta. So this Q component we calculated here, F is equal to F, that force, into sine beta upon sine alpha plus beta, and this R component, so this R oblique component of that force. So compare these two. R is equal to F sine alpha upon sine of alpha plus beta. So just see both of these two formulas. What is, like, observe here, Q is equal to F into sine beta. Sine beta, that means it is not making an angle with that Q. It is beta angle, sine beta upon sine of alpha plus beta, and denominator is same here. Sine alpha plus beta, sine alpha plus beta is same. Only this F here also same. Only difference is this alpha and see beta, it is making an angle. See with this Q force, that F force makes an angle alpha, but here at numerator there is beta. So just remember it like that way. So see those oblique components. If you will calculate oblique components of any force, then you will need this, both of these two, this alpha also and this beta also you need. In our perpendicular components, we saw that only one angle is also sufficient to calculate those perpendicular components, but here in oblique components we will need two angles, both two angles, like that components are forming with that force. So this is all about non-perpendicular or oblique components. Q is equal to F into sine of beta upon sine of alpha plus beta. So alpha plus beta, that means this sum of this alpha plus beta. So this part alpha plus beta, this part alpha plus beta, and this F is same here in Q component also, and in R component also. Only this beta and this alpha is different. So if you will calculate Q component, Q oblique component force, then in numerator take this beta angle, and if you will calculate r oblique component, then consider this alpha as in numerator, alpha angle in numerator. So I think you all understand this concept. Thank you very much.